The Pacific, late 1944. A gray morning fog drifts over Japan's eastern coast as a group of naval scientists huddle around a grainy set of reconnaissance photographs. The images, taken by a reconnaissance float plane, show something that should not exist: a U.S. submarine surfacing briefly near the Caroline Islands, its deck hatches opening not to fire torpedoes, but to release a small, winged machine. They watch as the strange object lifts into the air. Guided by no visible pilot, its shadow flickering over the ocean before vanishing into cloud. Confusion ripples through the room. The leading physicist adjusts his glasses, muttering that it must be a mistake, perhaps a seaplane launched by catapult. But another scientist points to the scale markers. Too small for a cockpit. Too steady for wind drift. Silence follows. Someone whispers, "It flies by itself?" In that single moment, disbelief turns to alarm. The empire that once prided itself on its engineers had just glimpsed a future it did not yet understand. A submarine launching an aircraft with no pilot at all. By 1942, the Pacific Ocean had become an enormous battlefield of attrition, one where distance, fuel, and production determined destiny as much as bravery. Japan's early dominance, carved through surprise and precision, was already beginning to erode beneath the weight of American industry. The United States had entered the war late, but with a momentum that defied comprehension. Every month brought new ships, new aircraft, and new technologies into the fight. The Imperial Japanese Navy, stretched thin across thousands of miles, found itself locked in a battle it could not replace fast enough. The Americans, by contrast, were learning to fight wars through machines, turning engineering laboratories into arsenals of invention. Beneath the surface of the Pacific, the U.S. Navy's submarine force was waging a silent campaign that slowly strangled Japan's supply arteries. Tankers, cargo ships, and convoys vanished into the depths, victims of torpedoes launched from steel predators hidden beneath the waves. Yet even that devastating success did not satisfy the restless imagination of America's wartime scientists. They were asking a different question. Could submarines do more than sink ships? Could they strike from beneath the ocean with weapons that didn't even need human pilots? In laboratories scattered across the American mainland, from the Naval Research Laboratory in Washington, D.C., to the Fairchild plants in Long Island, experiments were quietly underway. The technology of remote control, first tested on radio-guided target drones, was maturing faster than expected. In 1942, engineers had already flown small aircraft by radio from the ground. It was crude and unpredictable, but it worked. And in a war driven by innovation, even a fragile success was a starting point. The U.S. Navy's Bureau of Aeronautics began investigating how these assault drones could be adapted into offensive platforms. The TDR-1, developed by the Interstate Aircraft Corporation, emerged as one of the earliest operational attempts. A twin-engine, unmanned aircraft guided by television camera and radio link. It could carry 2,000 pounds of explosives and be piloted remotely from another aircraft. Though its system was primitive, analog signals transmitted to a small cathode ray screen, it marked the first real experiment in long-distance, precision attack. But a new idea soon surfaced within naval circles. What if the launching platform wasn't another plane, but a submarine? The theory seemed impossible at first. Submarines were already cramped, dangerous, and vulnerable when surfaced. Yet for visionaries like Rear Admiral Ralph Christie, the idea held terrifying potential. A submerged submarine could emerge briefly, launch an unmanned strike aircraft, and then vanish again, attacking coastal bases, bridges, or anchored fleets without ever revealing its crew to counterattack. It was stealth layered upon stealth. While such an idea seemed decades ahead of its time, the technical pieces were slowly coming together. Compact folding-wing drones, radio command systems hardened for saltwater interference, and specialized catapult systems were being tested by mid-1943. Even the TDR-1's design was modified with detachable wings and sealed compartments that could fit within the dimensions of a submarine hangar. These efforts were not widely publicized, not even within the Navy's own ranks. To most officers, they were eccentric distractions from proven weapons like torpedoes or bombers. But to the handful of engineers laboring over oscilloscopes and control cables, they were something else entirely. A glimpse of a future war fought not by men, but by machines obeying human will from miles away. By late 1943, the first field demonstrations took place near the Solomon Islands. Several TDR-1 drones were launched under real combat conditions, guided by TBM Avenger aircraft. The results were mixed. Some hit their targets, others veered off course. But the lessons learned were invaluable. The U.S. Navy now had proof that radio-guided, pilotless bombers were more than theory. Behind the scenes, submarine engineers began modifying vessels like the USS Cuttlefish and USS Tambor, experimenting with specialized deck containers that could house and launch aircraft-shaped drones. The tests were dangerous. One mishandled pressure valve could flood the entire system. But the concept advanced steadily. America was reaching into a technological horizon no other nation could touch. For Japan, whose scientists were still struggling to refine jet propulsion and radar, the idea of an unmanned, submarine-launched aircraft bordered on science fiction. They had developed remarkable machines like the I-400 submarine aircraft carrier, but these still relied on human pilots and physical catapults. The notion of a machine flying without, a man inside, and launched from beneath the sea, was an affront to both engineering logic and the Bushido spirit of combat. The Americans were quietly rewriting the rules of war, even as their enemies failed to realize it. The fog of the Pacific hid many things: submarines, convoys, and secrets. But beneath that fog, a new kind of warfare was being born. Invisible, remote, and terrifyingly precise. By 1944, the United States had transformed itself into an industrial colossus of invention. Every factory, university, and naval yard buzzed with purpose. The Manhattan Project was consuming unimaginable resources under a veil of secrecy, while other programs, less famous but equally revolutionary, pushed the frontiers of automation, guidance, and control. Among these was the little-known initiative to create a submarine-launched assault drone, a concept so bold that even some of its own architects doubted whether it could ever see combat. The Naval Aircraft Factory in Philadelphia had already produced hundreds of the TDR-1 drones by mid-1944. These wooden-framed craft, powered by twin radial engines, carried a television camera in the nose and a radio control receiver tuned to a mother aircraft. From there, a remote pilot would watch a flickering image on a CRT screen and steer the drone toward its target. It was the first primitive fusion of aviation and electronics, a direct ancestor of modern UAVs, yet one obstacle remained: distance. The TDR-1 relied on a signal relayed from the sky, but what if that command link came from below the waves? The Navy's engineers began drafting plans for a submarine that could surface, unfold a drone, and launch it before diving again, all within minutes. This would give the United States something entirely new: a stealth strike platform that could hit coastal installations or enemy fleets without risking human lives. At the same time, Japan's scientific community was moving in a very different direction. Rather than automating warfare, they pursued human extremes: kamikaze tactics, manned torpedoes, and suicide submarines. Where the Americans sought distance and precision, the Japanese sought sacrifice and willpower. Both paths reflected the philosophies of their societies: America's technological pragmatism versus Japan's spiritual idealism. Inside Japan's military research circles, there were warnings. Some physicists who had studied in Europe before the war, familiar with Western radio control experiments, feared the Allies might already possess such advanced systems. But their concerns were brushed aside by officers who believed human courage outweighed machinery. Japan still saw warfare as a test of spirit, not circuits. Meanwhile, across the Pacific, American testing continued. The U.S. Navy's Special Air Unit, under Lieutenant Commander Delmar Fahrney, the man later known as the father of drones, pioneered radio-guided weapons and worked on adapting them to naval conditions. He understood the oceans as not just a battlefield, but a launch platform. His experiments on remote guidance, gyroscopic stabilization, and control frequency separation laid the foundation for what naval intelligence would later call submarine air weapon integration. It was not simply about building a drone, it was about merging two domains of warfare that had never coexisted before: air and sea, automation and stealth. Every test moved the Navy closer to realizing the concept that Japan's scientists would soon struggle to believe. By mid-1944, the Pacific War had entered its most brutal stage. The Japanese home islands were under constant air attack, and their defensive perimeter was shrinking. Yet their military command still underestimated the scale of American experimentation. Their spies in Hawaii and the Philippines reported increasing submarine activity, but few understood that beneath those decks, tests for unmanned flight mechanisms were underway. In the summer of 1944, near the Solomon Islands, the Navy carried out its most daring trials. A modified submarine surfaced under radio silence. On its deck, technicians assembled a small aircraft-like drone, its fuselage sealed in wax to resist salt water. The engines ignited. It launched successfully, flying toward a distant target hulk. A decommissioned barge. Moments later, the barge erupted in a fireball. The weapon had struck dead center. Word of the test reached Washington within hours. The system worked. A submarine could now deliver an unmanned aircraft directly from the sea. The technology was crude, the control limited, but the principle was proven. The Navy had crossed into a new dimension of warfare, one that Japan could neither match nor fully comprehend. For Japanese scientists, this revelation would come too late. By the time intelligence reports and fragments of wreckage reached Tokyo, the American fleet had already surrounded their empire. When they studied the components, radio gyros, vacuum tubes, servo motors, they were stunned. The circuits were delicate yet resilient, engineered for precision that Japanese factories, crippled by bombings and shortages, could no longer replicate. The idea that a submarine could launch a pilotless aircraft into combat defied every assumption they held about technology and warfare. To them, it was not just a new weapon. It was evidence that America was fighting a different kind of war altogether. And as Japan's scientists stared at those fragments under the dim light of their laboratories, one truth began to sink in. The future of warfare had already arrived. And it was not human. To understand how this weapon reshaped military thought, one must see it not as a single invention, but as a convergence of 5 revolutionary forces: technology, tactics, psychology, leadership, and strategy. Each angle reveals a fragment of how America's engineers achieved what Japan's scientists believed impossible: merging submarines and drones into a single, seamless weapon system. The heart of this concept lay in a marriage between incompatible elements: a submarine, which thrived in silence and concealment, and an aircraft which demanded air, thrust, and visibility. Every technical challenge seemed insurmountable. Saltwater corroded electronics. Pressure differentials warped airframes. Even the idea of storing a fragile, propeller-driven drone within a submarine hull seemed absurd. But America's engineers were problem solvers first, dreamers second. They drew inspiration from earlier naval aviation experiments: folding-wing seaplanes, collapsible scout aircraft, and radio-guided target drones. At facilities in New Jersey and California, Fairchild and Interstate engineers created modular control units sealed in watertight casings. The drones' vacuum tubes, once fragile, were redesigned with shock absorbers to survive pressure shifts during surfacing. Each successful test was a quiet miracle of patience and precision. The wiring had to survive condensation. The servo actuators had to respond through fluctuating magnetic interference. And the radio signals had to pass through atmospheric noise with clarity. America's secret advantage lay in its industrial base. Factories capable of producing precision components by the thousands, and universities filled with mathematicians and physicists who could refine control theory in real time. The result was a functional prototype, a submarine deck container that could store, fuel, and launch an unmanned aircraft in under 5 minutes. Though bulky and experimental, it represented a quantum leap in naval warfare. The Japanese, with their limited access to refined metals and precision manufacturing, could not even replicate its components. Before 1943, submarines were viewed as hunters of ships and little else. Their weapons were torpedoes, their victories measured in tonnage sunk. But the concept of launching an aircraft from beneath the sea turned that doctrine on its head. Imagine, for a moment, the tactical impact. A submarine surfacing hundreds of miles from any base, releasing a drone that could fly inland to strike radar stations, oil depots, or even airfields. It could bypass anti-aircraft defenses, deliver explosives, and vanish without risking a single pilot. If the enemy detected it, there would be no one to interrogate, no wreckage revealing a flight plan, only mystery and fear. This idea was centuries ahead of its time. It would not reach full maturity until the 1950s, when the U.S. Navy began launching cruise missiles from submarines. But in the 1940s, even the first field trials hinted at a new kind of warfare, one where submarines became silent airbases. The Japanese Navy, ironically, had pursued a similar concept in human form. Their massive I-400 class submarines could launch 3 Aichi M6A Seiran float planes, each manned by pilots willing to die in the mission. It was a marvel of design, but still tied to the human body. The Americans had gone further, stripping man from machine entirely. For commanders like Admiral Ernest King, such weapons represented the future. Controlled warfare with minimal risk. Every successful test reaffirmed that machines, when guided properly, could achieve precision impossible for flesh and blood. In Tokyo's Naval Research Institute, disbelief became the first reaction to intelligence reports about unmanned American aircraft. The very concept violated deeply ingrained cultural notions of warfare. To the Japanese, combat required human spirit, the will to sacrifice oneself for emperor and country. Machines were tools, not warriors. When Japanese scientists studied captured fragments of TDR-1 drones, they struggled to comprehend the philosophy behind them. Wires, servos, and gyros lay scattered across their tables, evidence of a logic alien to their own. The Americans were building weapons that didn't need belief, courage, or emotion. To many within Japan's military hierarchy, such inventions felt dishonorable, a cold replacement for the warrior's soul. But among younger engineers, especially those trained abroad before the war, fascination replaced disdain. They realized the Americans were not simply inventing machines, they were inventing a new relationship between humans and technology. That psychological shift would haunt Japan long after the war ended. The very systems they dismissed as un-Japanese would later define modern warfare. Drones, guided missiles, automated control. In the laboratories of 1944, the seeds of that reckoning had already been planted. The greatest revelation of the submarine-launched drone was strategic, not mechanical. For the first time in history, a navy could project power without physical occupation. The weapon didn't need bases, refueling stations, or pilots to train and feed. It only required a submarine and a radio signal. This approach symbolized America's broader wartime mindset: victory through industrial scalability and efficiency. Where Japan fought for control of territory, the United States fought for control of systems, logistics, communication, production. The drone was simply the next logical extension, a weapon that combined precision, distance, and expendability. To American strategists, the implications were enormous. Submarines could approach enemy coastlines undetected, launch reconnaissance or assault drones, and vanish. It was asymmetric warfare in its earliest form, attacking from where the enemy least expected and could least retaliate. For Japan's military command, this represented an existential nightmare. Their empire was vast but static. Their enemies were mobile, invisible, and increasingly automated. The drone was not merely a weapon. It was a declaration that the future battlefield would no longer need the soldier's body. Each of these angles, technological, tactical, psychological, and strategic, revealed one simple truth. America was no longer just fighting Japan's navy. It was fighting Japan's entire way of thinking, and as the Pacific tightened around the shrinking empire, a new dimension of this story emerged. One not of machines or tactics, but of morality itself. While Japan's engineers debated the meaning of unmanned flight, America's factories had already turned that dream into mass production. The assembly lines that built Liberty ships, jeeps, and bombers could just as easily produce guidance units, control servos, and miniature gyros. What made the submarine-launched drone possible was not simply genius, it was scale. In the Midwestern heartland, factories originally designed for radios and home appliances were converted into drone component plants. Women technicians soldered resistors and wound copper coils for remote control systems, often without knowing their purpose. They were building pieces of a weapon so secret that even many officers in the field didn't know it existed. By late 1944, America's industrial output had reached a point of surreal abundance. Where Japan struggled to refine enough aluminum for a handful of aircraft, the United States could experiment with failures without fear. If a prototype sank, another would be shipped within weeks. It was this redundancy, this luxury of learning through trial, that gave the U.S. an almost evolutionary advantage. Even the choice of materials reflected industrial strategy. The TDR-1's wooden frame allowed for rapid construction and avoided using critical metals. Its engines came from standard civilian models, modified only slightly for naval operation. America had turned improvisation into doctrine. For Japan, where factories were bombed daily and supply chains shattered, such innovation was unattainable. The Americans were no longer fighting within the same timeline of development. They were accelerating through it. In a single year, their engineers accomplished what would have taken Japan 5. The industrial machine itself had become an instrument of war, a living organism of logistics, electricity, and willpower. It wasn't just that America could build submarine-launched drones. It was that no other nation on Earth had the capacity to build enough of them to matter. As the war neared its end, ethical questions began to surface quietly in the minds of those who built these machines. Could a pilotless weapon, detached from human risk, still hold moral accountability? Inside the Naval Research Laboratory, engineers often debated the nature of their invention. Some felt pride. They were saving pilots' lives. Others sensed unease. Were they also removing conscience from the equation of war? The television-guided bomb did not feel the heat of the explosion, nor hear the screams of its victims. For the first time in history, destruction could be witnessed remotely, through the indifferent eye of a cathode ray tube. These questions haunted only a few, for wartime necessity silenced hesitation. But they marked the birth of a new moral age, one that the Japanese scientists would later confront during Reconstruction. When they examined captured American drone components after the war, many were awestruck not just by the engineering but by what it implied. that warfare was becoming impersonal, mechanical, and abstract. In the East, the warrior's honor had always required risk, the possibility of death as proof of devotion. In the West, technology was beginning to replace sacrifice with efficiency. America's unmanned systems symbolized a cold, utilitarian vision of warfare, one that traded valor for results. This philosophical divide ran deeper than strategy. It revealed a cultural collision between two civilizations, interpreting progress through entirely different moral lenses. Japan's own use of suicide weapons, manned torpedoes, and kamikaze planes represented the extreme of human-centered warfare. America's remote drones represented the opposite, the elimination of the human altogether. Both sought the same goal, victory, but from opposing ends of the human spectrum. In that contrast lay the true story of the submarine-launched drone. It was not just a weapon. It was a mirror reflecting two visions of civilization. One believed salvation lay in courage, the other in control. After Japan's surrender, American technology flooded into scientific circles across Tokyo, Osaka, and Kyoto. For many young Japanese engineers, seeing the remains of a submarine-launched drone was less humiliation than revelation. They studied the vacuum tubes, the relays, the telemetry systems, and realized the future they had missed. Japanese scientists were not without brilliance. Before the war, their universities had produced remarkable breakthroughs in metallurgy and aerodynamics. But wartime isolation had starved them of information. Now, faced with physical evidence of America's progress, they experienced something rare: admiration in defeat. To them, these drones represented more than victory. They represented possibility. The combination of radio control, gyroscopic stabilization, and visual feedback inspired post-war developments in robotics and aerospace. Many of the post-war Japanese engineers who built television systems, cameras, and later industrial robots had studied American drone components first. Thus, the technology that once symbolized the collapse of their empire became the blueprint for their resurrection. Out of the ashes of disbelief came innovation, a continuity of curiosity that bridged the wartime divide. Each of these angles, industrial, moral, and scientific, revealed how one invention could transform not only the battlefield, but the human imagination itself. The submarine-launched drone was not a weapon of mass destruction. It was a weapon of mass realization. It showed Japan that the future belonged not to those who fought hardest, but to those who thought farthest. And that realization would become painfully clear in the months that followed, when the Americans finally tested their invention in combat, and Japan's disbelief turned to stunned silence. It began with an experiment cloaked in absolute secrecy. In early 1945, deep in the Pacific, the U.S. Navy authorized a limited series of operational tests involving submarine-deployed assault drones. The vessel chosen was an aging Tambor-class submarine, modified in dry dock with a sealed cylindrical hangar fitted to its aft deck, a crude forerunner of the missile tubes that would define the next generation of warfare. The mission plan was simple in outline, complex in execution. The submarine would surface briefly near an uninhabited island, launch the drone toward a pre-selected target hulk, and then dive immediately to avoid detection. The drone itself, a modified TDR-1, had been stripped of unnecessary systems, fitted with foldable wings, and a new ignition sequence that could tolerate brief exposure to sea spray. Every crewman aboard that submarine knew the risk. Surfacing during daylight near Japanese patrol lanes was suicide. But the potential reward, a proof that manless warfare could begin from beneath the ocean, outweighed every danger. At dawn, the submarine broke the surface. Water cascaded off its steel skin. The drone, encased in its cylindrical housing, was rolled out along steel tracks. Technicians, sweating in silence, unfolded its wings and attached the twin propeller assemblies. Its nose camera flickered to life, transmitting its ghostly black-and-white image to the control console within the submarine's pressure hull. Camera feed stable. One technician whispered. "Signal strong!" The drone's engines roared, shaking the calm Pacific air. For a fleeting second, the submarine's deck was a makeshift runway, a steel island between two worlds. Then the clamps released. The small aircraft lurched forward, lifted free, and vanished into the low clouds. The men below watched its progress through a grainy monitor. The first submarine crew in history to pilot an aircraft remotely. The signal was faint but steady. The drone banked left, leveled, and began its attack run on the derelict ship anchored several miles away. A few seconds later, the screen flared white. The image cut out. Moments afterward, the submarine's periscope caught sight of a distant orange bloom rising over the horizon. The target was gone. For the crew, there was no cheer, no celebration, only a profound, unsettled silence. They had just witnessed something that defied a century of naval doctrine. A weapon had flown, struck, and destroyed. Without a pilot, without exposure, without warning. The report reached Pearl Harbor, then Washington. The evaluation was clear. The concept worked. It was rough, it was unrefined, but it worked. The submarine-launched drone was no longer theoretical. It was operational. The Navy, consumed by other priorities, the atomic program, the island-hopping campaign, and the race toward Okinawa, quietly shelved large-scale deployment. But its meaning was not lost on those who understood what had just been proven. The ocean, once a place of hidden predators, could now project power into the air. Thousands of miles away, fragments of this success filtered into Japanese intelligence channels. Reconnaissance aircraft near Truk Lagoon had reported unusual sightings, U.S. submarines surfacing momentarily, followed by unidentified aerial craft. At first, the reports were dismissed as hallucinations under stress. But when a Japanese patrol ship recovered floating debris bearing English serial codes and fragments of radio tubing, curiosity turned to alarm. The wreckage was sent to Tokyo's Naval Technical Research Laboratory. There, under dim fluorescent lights, a group of engineers laid the pieces across a long oak table. Fuselage skin made of laminated plywood, gyroscopic mounts of brass, wires connecting primitive transistors, a lens that could only have been used for imaging. "This isn't a reconnaissance balloon," one engineer murmured. "It's a flying bomb, controlled by radio." The room fell silent. The chief scientist, a veteran of pre-war European study, recognized the circuitry immediately. A Western adaptation of German radio control concepts taken to their extreme. What shocked him wasn't that it existed, but that the Americans had mastered it to the point of launching it from submarines. Japan's own radio-guided experiments, limited by material shortages, had barely progressed beyond prototypes. Their vacuum tubes burned out after minutes, their transmitters overloaded under heat. Here, laid out before them, was proof that the United States had solved every one of those problems, while mass-producing the parts in quantities Japan couldn't dream of. It wasn't merely the technology that unnerved them. It was what it represented, a fundamental shift in the philosophy of war. America had removed the pilot, the symbol of courage, sacrifice, and skill, from the equation entirely. One Japanese naval officer reportedly said, "They've made the pilot unnecessary. What will become of honor when machines fight?" No one answered. The silence said enough. The discovery spread quietly through Tokyo's academic circles, whispered about in universities and laboratories. For some, it was terrifying. For others, mesmerizing. The empire that had prided itself on divine spirit had just been confronted by a civilization that now fought with invisible hands. And while Japan's scientists struggled to comprehend the weapon's full scope, the Americans were already preparing their next demonstration, one that would burn the concept into history forever. Spring 1945. The Pacific War was entering its final convulsions. Japan's fleet lay broken, its skies owned by American bombers. But beneath those same waters, a quiet experiment continued, unseen, uncelebrated, and decades ahead of its time. From the Mariana Islands to Ulithi Atoll, a handful of U.S. submarines were being modified under classified orders. These weren't war patrols anymore. They were data missions. The objective? Record the effectiveness of launching radio-guided drones from mobile underwater bases. Each trial was a step toward what naval strategists would one day call deterrence without presence. The most successful of these final tests came in late May 1945. The submarine USS Barbaro surfaced. At dawn under a low ceiling of mist, her crew had rehearsed the drill a dozen times in the dark. Assembly, ignition, control signal lock. But this time, the stakes were real. The drone would carry a 2,000-pound payload against a derelict freighter target off Tinian. Inside the control cabin, the air hummed with voltage, the operator's eyes fixed on the greenish flicker of a cathode ray screen. Watching the drone's forward camera feed, a shaky monochrome view of open ocean, then the faint outline of the target hull. Bearing steady. Speed consistent. The radio signal pulsed flawlessly through the humid air. The operator adjusted the control yoke, guiding the unmanned craft into a shallow dive. The crosshairs steadied. The screen blurred, then bloomed white. Moments later, a thunderous boom rolled across the sea. From the periscope, the commander watched the black column of smoke rise where the target had been. No human pilot, no risk, no loss. That was the turning point. Not a battle, not a declaration, just a small, perfect explosion that confirmed humanity had crossed an invisible line. For years, the Japanese military had worshipped precision born of discipline and sacrifice. Now, they were watching precision born of circuitry. Intelligence officers scrambled to make sense of intercepted signals, aerial sightings, and captured debris. To many within the Imperial Command, the reports sounded like madness. Submarines launching flying bombs. Pilotless aircraft over the Pacific. The skepticism ran deep, but the evidence was undeniable. One captured Japanese diary from a naval officer later recorded, "We used to believe machines could never replace men. But perhaps it is not about replacement. Perhaps it is about who commands from further away." That reflection captured the essence of Japan's shock. It wasn't only the loss of technological parity, it was the loss of philosophical certainty. Back in Tokyo, the recovered components from earlier American drones were studied feverishly. Engineers sketched diagrams of signal frequencies, servo linkages, and lens housing mounts. They tried to reverse engineer the system, but the math betrayed them. Japan's industrial ruin had left it without the micro-precision manufacturing needed to replicate such control fidelity. For every Japanese scientist staring at those schematics, the message was brutally clear. America wasn't merely ahead in production. It had entered a new dimension of warfare altogether. By mid-1945, even as B-29s incinerated Japan's cities, whispers circulated within the research community that the submarine-launched drone might only be the beginning. If aircraft could be guided remotely, what of missiles? What of bombs that needed no pilot, no launch plane? That speculation reached its dreadful answer in August. The atomic bombings of Hiroshima and Nagasaki rendered every other weapon suddenly small. Yet to the few who understood, the submarine drone remained equally symbolic. Both technologies were children of the same philosophy. Warfare without presence. Machines now extended human reach farther than morality could follow. In the aftermath of surrender, Allied investigators uncovered Japan's own secret projects. Suicide aircraft, rocket-assisted torpedoes, even experimental gliders, all manned, all fatal. None compared to the cold efficiency of America's remote control craft. The Japanese engineers who had dismissed unmanned flight as fantasy now faced its reality, etched in their defeat. A report submitted to U.S. Naval Intelligence in late 1945 summarized Japan's reaction succinctly. The enemy expressed disbelief that such a degree of control could be achieved by wireless command. Upon demonstration, their scientists were observed to be deeply disturbed, not by the weapon's power, but by its implication. Indeed, the implication was haunting. The submarine-launched drone wasn't a decisive weapon of Right-Tuo. It was a prophecy, a glimpse of the post-war world, of guided missiles, cruise systems, and eyes in the sky that would one day patrol without rest. The Japanese scientists, standing among the ruins of their empire, realized this long before the rest of the world did. They had witnessed the birth of an idea, the separation of will from weapon, of man from machine. And though they had lost the war, they had seen the future. That future, cold and silent, would soon redefine not only warfare, but the very meaning of human control. When the war finally ended in August 1945, the submarine-launched drone remained an obscure entry in the labyrinth of classified naval experiments. Overshadowed by the atomic bomb, the jet engine, and the V-2 rocket. Yet, within the quiet corridors of the U.S. Navy's Bureau of Ordnance, it was viewed as something perhaps even more profound. For the first time in recorded history, a nation had successfully launched a flying weapon from beneath the sea, a feat of coordination between air, sea, and radio technology that no other military had come close to achieving. In the official post-war debriefings, American engineers noted that the TDR-1 and its submarine variants had achieved operational promise, limited only by transmission range and visibility. It was a polite way of saying that the weapon had worked, but the world was not yet ready to understand its significance. The submarine drone had not been designed to win World War II. It had been designed to invent the next one. As demobilization swept through the armed forces, many of the scientists and officers behind the project quietly transitioned into post-war research programs. Lieutenant Commander Delmar Fahrney, the same man who had supervised the Navy's first radio-guided aircraft, continued to refine guidance theory. His work directly fed into what would become the Regulus program in the 1950s, the Navy's first operational submarine-launched cruise missile. The link was unmistakable. The crude plywood drones of 1944 had become the conceptual ancestors of a new strategic age. The technology evolved faster than anyone had predicted. Within a decade, submarines were launching guided missiles capable of crossing continents. Within 2 decades, satellites and remote reconnaissance vehicles would orbit the Earth, performing tasks that once required armies of pilots and scouts. The lineage could be traced, step by step, to those first hesitant launches off the Pacific in 1944, when a handful of men watched a pilotless craft rise from the deck of a submarine and vanish into the mist. Across the Pacific, in defeated Japan, the weapon's legacy took on a different shape. When American occupation forces opened scientific exchange programs, they shared limited access to non-nuclear technologies with Japanese universities. In these laboratories, young engineers studied captured American control systems, servo mechanisms, television guidance tubes, and gyroscopic sensors. What they learned there would become the foundation of Japan's post-war electronics and robotics industries. Ironically, the very country whose scientists had once stared in disbelief at submarine-launched drones would become the world's foremost pioneer in automation. Many of those post-war researchers cited the shock of wartime defeat and the awe of American technology as their driving motivation. They sought not vengeance, but understanding. Meanwhile, within the United States, the moral questions raised by the drone's existence began to surface quietly in academic circles. Could a weapon operated remotely still be governed by the laws of war? What happened to accountability when killing became a signal transmission rather than a physical act? These debates never reached the public then, but their echoes would resound decades later, when unmanned aircraft once again filled the skies, this time not as prototypes, but as instruments of global surveillance and strike. The submarine-launched drone had left no famous battles, no parades, no medals. Yet its ghost lingered in the logic of modern war, unseen, efficient, and inevitable. For the Japanese scientists who first encountered its wreckage in 1945, it was more than a curiosity. It was a message from the future, a message written not in ideology, but in circuitry. And as they dismantled those broken machines in the ruins of their laboratories, they could not have known that within a single generation, the children of their defeated nation would carry those same ideas of precision, control, and automation into a new world of peace, production, and progress. The age of machines had begun. When the American occupation began, teams from the Office of Naval Intelligence and the U.S. Strategic Bombing Survey entered Japan not just to document destruction, but to measure understanding. They found a nation whose scientific community was stunned, not by the devastation of its cities, but by the realization of how far its science had fallen behind. Inside the remnants of the Naval Technical Research Laboratory in Tokyo, American officers discovered disassembled fragments of captured U.S. drone components, neatly preserved and catalogued. The Japanese engineers had labeled every piece, servo housing, control rod, vacuum tube, as if they were artifacts from another civilization. On the walls hung chalk sketches of control circuits and waveform diagrams, attempts to reverse engineer what they had only partially understood. The notes spoke of admiration, not resentment. Unmanned, guided by radio. Extraordinary. Beyond our reach. In post-war interviews, several Japanese scientists admitted that these discoveries had shifted their entire perception of warfare and technology. For years, they had equated progress with courage, equating human sacrifice with strength. Now they understood that the true measure of power lay in systems, not spirit, in the capacity to connect science, industry, and imagination under a single command of purpose. American advisors noticed this transformation immediately. Many of the same Japanese researchers who had studied the wreckage of the submarine-launched drones were soon invited into reconstruction programs. They became technical interpreters, laboratory assistants, and eventually innovators in their own right. Japan's new universities, rebuilt under American guidance, began teaching subjects unheard of during the war: control systems engineering, industrial automation, and cybernetics. By the early 1950s, those same men were developing servo-controlled factory robots and guided camera systems. The very principles once used to guide a weapon through the Pacific sky now controlled mechanical arms on assembly lines in Nagoya and Yokohama. What had once been a weapon of destruction had quietly become a philosophy of creation. The American Navy, meanwhile, continued its silent march toward the future. In 1947, experimental radio-controlled aircraft were tested from submarines in the Atlantic. By 1953, the Regulus-Thurin missile, the spiritual descendant of the TDR-1, made its first successful submarine launch. It could travel 500 miles at jet speed and carry a nuclear payload. The dream born in secrecy during the Pacific War had become the backbone of the Cold War deterrent. In a classified report declassified decades later, one Navy engineer reflected on that lineage with quiet pride. It began with a plywood drone no one believed in. It ended with a missile that could end the world. For Japan, the drone remained a symbol of both defeat and enlightenment, a reminder of the moment when they first saw the technological horizon they had failed to reach. But in that recognition came humility, and in humility, rebirth. The engineers who had once stared in disbelief at American radio circuits went on to design televisions, transistors, and industrial robots that would redefine global manufacturing. Their nation, crushed by war, rose not through conquest, but through mastery of automation, the very field that had once symbolized their downfall. Thus, the submarine-launched drone's true legacy was not its explosions, but its influence. It bridged the moment when human ingenuity crossed from mechanical warfare to electronic warfare, from courage to control. It had shown both nations what the future demanded: precision, calculation, and imagination bound to the cold discipline of science. By the time the Cold War began, Japan had re-emerged as a technological giant. American scientists, once their enemies, now collaborated with them. The line between conqueror and conquered blurred beneath the common pursuit of innovation. And though few remembered the primitive drone that once startled Japanese scientists in 1944, its shadow stretched quietly across every satellite, every missile, every unmanned craft that followed. A single wooden aircraft, launched from the deck of a submarine, had altered not just the course of war, but the destiny of modern civilization. In the end, the submarine-launched drone was not remembered for its victories, but for its vision. It existed in a moment of transition, between the world of courage and the world of code, between human will and mechanical precision. What began as an experiment in naval innovation became the seed of an entire era, the age where machines would extend man's reach beyond the limits of flesh, distance, and fear. To the Japanese scientists who first encountered it, the weapon was incomprehensible, not because it defied physics, but because it defied philosophy. They had built a war culture on the sanctity of the human act, the pilot's sacrifice, the sailor's resolve, the soldier's duty. The American drone dissolved all of that into circuits and radio waves. It was war without witness, destruction without danger. And yet, in that coldness, there was also a strange kind of mercy, a path away from the necessity of dying to prove devotion. History would later show that this invention, born from desperation and obscurity, quietly shaped the next century. The idea that a submarine could reach from beneath the sea and strike through the sky foretold the cruise missiles of the Cold War, the reconnaissance drones of Vietnam, and the unmanned fleets that today patrol the world's oceans. Every remote weapon, every guided vehicle, carries within it the ghost of that first launch in the Pacific Mist of 1944. But its deeper legacy lies in what it revealed about humanity itself. That progress, once unleashed, cannot be contained within morality or memory. It evolves, adapts, and escapes the intentions of those who first imagined it. For Japan, the shock of defeat transformed into enlightenment. For America, innovation became a burden of foresight. And for the world, the submarine-launched drone became the quiet warning that every invention of power, however small, carries the blueprint of tomorrow's world, for better or worse. Somewhere in the Pacific, time has long since swallowed the traces of that first unmanned launch. The sea is calm again, but in the silence beneath its waves lies the echo of a question humanity still cannot answer. When machines begin to fight our wars, do we win, or do we disappear?